Hello everyone, welcome to the Unacademy. Let's crack GATE and ESE with India's largest online learning platform. Get the Plus subscription now and start accessing the unlimited live and the recorded video lecture by India's top educator. Myself, Ajay Das. I'm MTech in Computer Science. I have a teaching experience of 8 plus years. I have worked as a freelancer in many reputed institutes of India, and I have qualified the GATE exam 5 times. Along with that, I have also qualified the Chhattisgarh State Electricity Board exam with AIR 8 in 2010. So, download the Unacademy Learning app and start your preparation sitting anywhere, anytime. What you will get? This is the major question which always used to arise in everyone's mind. The first thing that you are going to have once you will take the subscription is the daily live classes. Second thing is the structure courses and PDF. Third one is the live test and quizzes and unlimited access. So my dear friends, the Unacademy has modularized two different things, two kind of subscription for you. One is the plus subscription and second one is the iconic. Okay, so these are the educators. So I am just displaying some of the educators who are associated with the Unacademy. To know more about the educators, what you can do, you can download the Unacademy Learning app and you can see the profile of the educator, their history and their results that he has produces in their career. So if you want to explore more about the educators, you just download the Unacademy Learning app. So my dear friends, under the GATE ASC, already you know there are various branches, but for which branches Unacademy is offering you for the GATE and ESE preparation, I have already mentioned over here, like CSIT, instrumentation, production, chemical, mechanical, electrical, electronics. So these are the branches for which the Unacademy is offering you the GATE and ESE preparation. So my dear friends, already I have told you that Unacademy is offering you two kind of subscription under GATE and ESE. One is the plus subscription and the second one is the iconic subscription. So second one is the iconic subscription and the first one is the plus subscription. So you can see over here, and let me tell you what is the difference between the plus and iconic. So these are the fee structure of the plus subscription. Since the green mark is mark over here, so these are the fee structure of the plus subscription. Suppose if you are taking a subscription of the 12 month, your fee structure will be 30,250, but once you will apply this code you will immediately get the 10% discount. Similarly, if you are taking the subscription for the 18 months, then your fee structure will be this, and for the 24 month your fee structure will be this. Suppose you are in a second year or the third year and you willing to prepare for the GATE 2022. Okay, so you can go slow, and in that situation either you can take the 18 month of subscription or you can take the 24 month of subscription. But if you are pass out, if you are pass out or in a final year, you can go for the 12 month of subscription. So I will advise, means all the students who are in second year, third year, go for the at least 18 or the 24 month subscription, and the remaining student for the 12 month of subscription. And in whatever the cases, if you will apply the code which is written over here IFA, immediately you will get how much? Minimum 10% discount. So whatever the fee structure is, your discounted fees will be like this. So these are the fee structure after the discount. These are the fee structure after the discount once you will apply the code IFA over here. So these are the fee structure under the plus subscription. Now let me tell you what is the iconic subscription. So my dear friends, in iconic, you can choose your personal coach who will guide you personally time to time and according to your performance, right? So in iconic subscription there are only two models, 12 month or the 24 months. Means if you are in a final year or the pass out, you can go for the 12 month of iconic subscription and your fee will be 45,000. And again if you are in a second year or the third year, you can go for the 24 month of subscription, that is the iconic subscription. Okay, so here what is written, no cost EMI available on 6 month and above subscription. Suppose if you want to pay in EMI form, then, and if you are taking the subscription of 6 month or above the 6 month, then no EMI cost will be applicable. What you can do, you can pay according to your bill monthly, right? So These are the iconic. Now let me tell you what are the things you are getting inside the plus and what are the things you can get inside the iconic, means the difference between plus and iconic. So my dear friends, if you are taking the subscription inside the plus courses, so what you are going to have, the first thing is India's best educator. So as you know, the Unacademy never compromise in the field of educators, because they already had the India's top educators, so no compromise in like quality. If no compromise in quality, you understand, no compromise in results. So second thing is the interactive live session, structure courses and PDF and live test and quizzes. So these are the things which you are getting inside the plus subscription. But let me tell you what is the difference between plus and iconic. Means all the things that you are getting in the plus you will get in the iconic, but what the extra thing you are going to have, so that is the personal coach. As I told you, you can choose your personal coach. Suppose there are 10 to 12 educators inside the computer science and IT. So out of 10 to 12 educators, you can choose anyone as your personal coach who will guide you personally time to time according to your performance, so that you can make your performance improve according to your study, right? So second thing is the personalized test analysis, means whatever the test you are appearing for, your test will be evaluated and you will be personally assisted, and all the doubts regarding with the test will be clear. And second third one is the study planner and the study material. So these are the extra things that you are going to have, and only after paying some of the extra amounts. Are you getting my point or not? Because you have seen in the iconic, your fee structure is 45,000 for the 12 month and the 60,000 for the 24 months. So again, if you will apply the code which I have written over there, that is the IFA, again you will get the minimum 10% discount. How much? Minimum 10% discount. Got it? So this is all about the things. Now let's come to the subject. Let's crack it. This is the slogan of the Unacademy, because we believe we will prepare you in such a way that you would be able to crack your exam in your first attempt. So let's start the subject. So today our subject is computer network, and the topic that we are going to discuss according to the GATE point of view is the media access control protocol. So my dear friends, already you know that inside the computer network there are various protocols. There are various protocols. So this is the one of the protocol under the media access control. Fine. Under the media access control. So all of you, am I audible? Am I audible? Tell me, guys. So I have considered a lot of problem related with the media access control protocol, but before that we have to learn the concept behind the media access control. Then we will come to the numerical part. Okay. So first of all, let me tell you what are the things that we are going to cover inside the media access control. So my dear friends, first try to understand what is the meaning of media access control. See, suppose there are various nodes. There are various nodes. Suppose this is the node A, this is the node B, and this is the node C, which are connected to a common medium. Which are connected to a common medium, or medium you can say the link. This is the link, and of course media access protocol is the part of data link layer. Is the part of data link layer. Means whatever the protocol inside the data link layer we are implementing, we will implement inside a particular link. Means this particular wire connection between two connecting point is called a link. Okay, so this is the common medium also. Yes or no? This is the common medium also. Now imagine a situation. Suppose node A, you can say this is the node A or station A. In computer network, we treat every node, whether it is a router, switch or computer, as a node, right? So suppose there is a node A, and node A at a particular time instance wants to transmit their data packet. Okay, and at the same time node C also wants to transmit their data packet. My dear friends, whenever you are connected with the network means if you are accessing any server means like if you are accessing the Flipkart server, or you are accessing the IRCTC server, or any one of the server like the Facebook or like OLX, anything. So must be either you will like try to access the some data from the server, or you will upload something to the server. Means in that situation only the packet will be moved to the network. Are you getting my point or not? So suppose I am assuming a situation that node A is trying to send its data packet, at the same time node C is also sending its data packet. So what will happen? Both the data packet will reach to the common medium. Both the data packet will reach to the common medium, and it will be collided. It will be collided. Are you getting my point? Once two different packet will be collided, okay, there will create a error inside the packet, and if there is a error it cannot be delivered to the destination, because once it will be delivered to the destination by the error control mechanism, the destination host will discard the packet. Are you getting my point or not? The destination host will discard the packet by using the error control mechanism. So here what will happen and what we are trying to understand from this particular concept. See over here, two different node or more than two different node are trying to access the common medium. Means if you are sending your data packet to the common medium, means you are accessing this medium. Suppose just imagine just imagine a real life example, right? Real life example. Okay, suppose two different vehicles are coming from two different sides. Okay, two different vehicles are coming from two different side, and this one is the common medium, or you can say this one is the common path. Okay, this one is the common path, and two different vehicles are coming from the two different path. And once they will reach over here, what does it mean? They are trying to access, this is the path which both the vehicles are trying to access. Then there is a chances of collision in this common point. There is a chances of collision in this common point. So whenever you are moving from this particular path, means what? You are accessing this path. Yes or no? You are accessing this path. So whenever you are trying to access this particular path, and if alone you will access this path, there will be no any collision. But if the multiple node at the same time, or the multiple like direction, from the multiple direction, if at the same time different vehicles are coming to the common path, there is a possibility of collision. So what we can say? We can say if the common medium is being accessed by multiple nodes, then there is a chances of collision. So how to reduce the collision? How to reduce the collision? That basically comes under media access control protocol. For that, we basically define the set of protocol. To reduce the collision, we basically define the set of protocols. So what will be the definition? The common medium, the common medium is being accessed by multiple nodes. Then there is chances of collision. There is a chances of collision. Then how to control the collision? How to control? And for this reason, we basically define we basically define set of protocol. We basically define set of protocols means a set of rules that each and every node has to follow. Protocols means a set of rules that each and every node has to follow if they want to communicate inside the network. Are you getting my point or not? So what are those set of protocol? What are those set of protocol that basically comes inside media access control? So now let me tell you what are the protocol we basically use in case of media access control. Media access control. See, the media access control basically divided for two different kind of network. One is called the contention service and second one is the contention. Okay. Now, what is the meaning of contention? Contention is an English term whose simply meaning is partition. Whose simply meaning is partition. Okay, a range where the collision will occur. So whenever I am saying the contention service means there will be definitely a collision. So if there is a definite possibility of the collision, then what will be our target? Our target will be to reduce the percentage of collision. So here our target is to reduce percentage of our target is to reduce percentage of call. This is our target. Okay, so in case of contention free means there is no collision. This is the collision free network means we will define such kind of protocol so that it will make the network as a collision free. So here percentage of collision is 0 is 0. So what are those protocol where the percentage of collision is 0? What are those protocol where the percentage of collision is 0? So we basically learn two different kind of protocol. One is the token ring and second one is the poly. Second one is the which are in our GATE syllabus. But in this situation, what we basically define, of course, if it is a contention service protocol or the network, then there is a definitely a collision. So our main target is to reduce the percentage of collision. So here we will study simply aloha, slotted aloha, okay, slotted aloha, and then aloha and slotted aloha, CSMA. You know the meaning of the CSMA, that is the carrier sense multiple access, and there is various persistent method. There is various persistent method inside the CSMA. There is various persistent method. Third one is CSMA by CD and CSMA by CA. Okay, the CD means collision detection and CA means collision avoidance. So this is the carrier sense multiple access by collision detection, carrier sense multiple access by collision avoidance. So my dear friends, this particular protocol is basically work in wired network, and this particular protocol is basically work in wireless network. I will tell you the reason, don't worry. I will tell you the reason why it can work in the wired network and cannot work in the wireless, and why we are defining the separate protocol for the wireless network. So I will discuss each and everything, so don't worry. And the fourth one is we will learn exponential back of exponential back of. So these are the different topics under the chapter media access control. So once you will mark as a gate point of view, as a gate point of view, then every year almost 1 to 2 questions were asked from this particular chapter. Almost 1 to 2 questions were asked from this particular chapter. Now you can imagine what is the importance of this chapter. Now you can imagine what is the importance of this particular chapter. Got it? So I will start from the contention service. And after completion of this, we will start the contention free protocol. Got it, everyone? Now let's start the contention service protocol. As I told you, I have divided the media access control protocol into the two parts. Okay, today I will discuss the part 1 and tomorrow I will discuss the part 2, and in the part 1 and part 2 I will cover everything related with the contention service as well as contention free. So just be with me if you really want to secure 1 to 2 means 2 to 4 marks in your GATE exam related with the media access control protocol. Got it? Now let's start. So first of all, we will try to understand each and every concept and then we will come to the numerical part. Okay. Now let's see. The first protocol is inside the contention service. The first protocol is Aloha. So in Aloha, how we can define any node can transmit their data frame at any time. Okay, any node can transmit their data frame at any time. My dear friends, you can imagine that if any node means if there is no foundation, if any node can transmit their data frame, then what will be the possibility of the collision? Means the possibility of the collision will be much more. If you are connected means if these are the node which are connected with the common medium, connected with the common, this is the common medium. Okay, connected with the common medium, and all are unrestricted. So if any node will transmit their data packet at any time, then the possibility of the collision will be high. So here, by the mathematical implementation, means by the practical implementation, it has been analyzed the percentage of collision is almost 87. Is almost 87%. Okay, now let's come. Next one is the slotted Aloha. See, from this particular part you will get the theoretical kind of questions. Okay, the numerical kind of question basically arise from the CSMA by CD and exponential backup algorithm. So we will understand each and everything. See over here, slotted Aloha. Now let's try to understand what is the meaning of slotted Aloha. Suppose there are 4 different nodes. Which are connected with common medium. This is the node A, this is the node B, this is the node C, and this is the node D. Okay, so in the earlier situation, like the Aloha, we have assumed that any node can transmit their data packets at any time. But here it will not happen. So since this is the slotted Aloha, so for every node, we have divided the entire timeline into a slot. And every node can transmit their data packet at the beginning of the slot. Just see over here. Just see over here. This is I'm representing a timeline. This is I'm representing a timeline. Okay. This is I have represented a timeline. So divide the entire timeline into a slot, and slot is nothing but a transmission time of a single frame. Transmission time of a single. We have divided the entire timeline into a slot, and this slot is equivalent to the transmission time of single frame. Okay, so by this we are representing time line. Okay, now suppose this is the timeline of node A, this is the timeline of node B, C and D. Okay, there are four different nodes which is connected with the common medium. So this is called time slot. This is called time slot, and this is equivalent to the transmission time. This is equivalent to the transmission time of a single frame. And you know how to calculate the transmission time of a single frame. So TF is nothing but is equal to L, size of frame divided by bandwidth. Size of frame divided by bandwidth. Now just imagine here we are having a frame, and here we are having a frame, and here we are having a frame, and here again we are having a frame. So what is happening over here? What is happening over here? At the same timeline, there are two different frames. Means these two frames 1 and 2 has been already collided. Means just imagine a situation like this. Means just imagine a situation. See, if any node wants to transmit a data packet, they cannot transmit at any time. They cannot transmit at any time. If it has to transmit, it will transmit at the beginning of the time slot. At the beginning of the time slot. Okay, let me tell you the situation of the Aloha. Similarly, let me tell you the situation of the Aloha, then you will be able to realize. This is the situation I am considering in case of C. This is the timeline. In case of Aloha, we do not divide into the time slot, but still I am considering to make you understand. Okay. Just see. This is the node A, B and C, and we are considering there are three different nodes which is connected with the common medium. Suppose at the particular time instance when the frame of A is in this point, then the frame of B is in this particular point. So what you are observing, it's this particular bit has been collided in between them. Similarly, if the frame of C is in this particular point, so what will happen? This particular bit of C has been collided with this particular bit of frame A. Means all the three frames are collided. This is the frame 1, this is the frame 2 and this is the frame 3. So what is happening over here? This kind of collision is happening. So you just see me on the screen, this kind of collision is happening. So suppose the transmission time, means suppose the transmission time of a single frame, imagine a situation where the transmission time of a single frame is 5 millisecond. Okay, so node A transmitted the frame at t is equal to 0. Okay, t is equal to 0 and node B has transmitted the frame at t is equal to 2 millisecond. So what will happen till the 2 millisecond the node A has been transmitted this much frame. If this is the entire length of the frame, then at the 2 millisecond it will transmit this much frame, and at the same time node B has started its transmission. So the first bit of node B will collide in between the frame of node A. Yes or no? In between the frame of node A. Are you getting my point or not? Like just you can again take the real life example also for the same thing. Okay, so this is the common path. Suppose one bigger vehicle is coming out and this has reached up to the this point. Okay, and at the same moment the another vehicles is coming. So what will happen? These vehicles will be collided in between them. In between them, yes or no? So what kind of collision is this? This is the this kind of collision, and that's why there is a more possibility. There is a more possibility. If you are not restricting any node in case of aloha, then this either front bit can be collided or front mid bit can be collided. So the front bit of another node can be collided anywhere to the first node. Are you getting my point or not? So this kind of situation can arise in case of aloha. But in case of slotted aloha, what we have done? We have restricted each and every node. If you want to transmit your data frame, then you have to transmit at the beginning of the time slot. Means, what does it mean? Just see over here. What does it mean? In case of slotted aloha. In case of slotted aloha, suppose the transmission time of a single frame is 5 minutes. Suppose actually it will be a 5 millisecond or the microsecond. Okay, but I'm assuming a 5 minutes. Suppose at 10 a.m. I have divided the entire time into a slot. 10 a.m., 10, 5 a.m. okay, and 10, 10 a.m. and 10, 15 a.m. in this way. So if any node wants to transmit their data frame, it has to transmit either in 10 a.m. okay, either in 10 a.m. If he missed to transmit at the 10 a.m., then the next time slot is 10, 5 a.m. Are you getting my point or not? Means no any node can transmit their data frame at 10, 3 a.m. Are you getting my point or not? Because the time slot we have considered here is difference is 5 minutes. Difference of each time slot we have considered the 5 minutes. So if any node wish to transmit their data frame at 10:03 a.m., it cannot transmit it. It cannot transmit it because the next time slot will appear at the 10:05 a.m. If such kind of things you have implemented, then this kind of collision will never occur. Means the front bit of first node cannot collide to the in between the another frame. Are you getting my point or not? So always, if suppose there is a possibility that two different node has transmitted their data frame at the same time, that is the at the same time slot, that is the 10 a.m. So what will happen? The front bit of both the node, the front bit of both the frame will be collided because they are reaching to the same time. Are you getting my point or not? So this kind of concept we basically implement in case of slotted aloha. Means what is the concept? If any node wish to transmit their data frame it has to transmit data frame, then it has to transmit at the beginning of time slot, at the beginning of time slot, time slot. So if missed, it has to wait, it has to wait for next time slot. It has to wait for next time slot. Means either you can transmit your data frame at the 10 a.m. Otherwise, if you missed in this particular time, then you have to wait for the next time slot. You cannot transmit in between this particular time slot. So if this thing is happening, then this kind of condition will arise. So only the frame transmitted by C and B is uncollided. Otherwise, the transmitted frame of A and D is collided. So only this is the node which has been collided, remaining are uncollided. So again, by restricting, means in the first protocol was the aloha, in the next protocol, that is the slotted aloha, we have created some restrictions. And by imposing some restrictions, we are just reducing the rate of collision. So in this situation, if you will talk about the percentage of collision, then this is almost 50%. Got it? This is almost 50%. Actually, all these parameter depends upon like how many nodes are connected with the common medium. But I'm just taking the standard value, okay, which was coming due to the real implementation. Got it? Now let's come to the CSMA, which is the more powerful protocol. Okay. So just see the next protocol, which is the CSMA. My dear friends, whatever the topic I am discussing right now, always the theoretical kind of questions will arise. I will tell you from where you are going to have a numerical kind of questions. CSMA. What is the meaning of CSMA? That is the carrier sends multiple access. Okay. Generally, whenever you are transmitting a frame, once it will reach to the medium, it will become a signal. So either you can say the signal or you can say the carrier. Are you getting my point or not? So the carrier is nothing but a form of signal. Means what will happen over here, if any node wants to transmit their data packet, what it will do, it will first of all sense the medium and then it will transmit. Suppose there are three connecting nodes. This is the node A, B and C. There are three connecting, okay, which is connected with the common medium. And suppose at a particular time instance, the node A is accessing the medium. Okay, means the data frame is transmitted through this medium by the node A. So in that time, if node A will sense the medium, what it will found? If node B and C will sense the medium, what it will found? The medium is BG. What it will found? The medium is BG. Okay. So what the node B and C will do? It will wait for some time until the medium will become the idle. So once the transmission of node A is completed, both the node will sense the medium and it will found the medium is idle, and both the node will transmit their data frame, and what will happen, again there is a possibility of collision. So you cannot 100% reduce the collision. Okay, what you can do, you can just reduce the rate of collision. Are you getting my point? You can make it like 18%, 15%, but you cannot make it zero, because once you will consider the different situations, you will be able to realize that the in any one of the protocol, you will find there is a less possibility of the collision, but there is a possibility of collision. Are you getting my point or not? So if at the particular time instance node A is accessing the node, in that particular time instance, whenever the node B and C will sense the medium, it will found it as a BG. So once the transmission is completed, both the node will found the medium idle, and immediately they will transmit their data frame, and the collision will occur. Are you getting my point or not? So what is the meaning of CSMA? What we are doing in case of this particular kind of protocol? In case of this particular kind of protocol, this is the sense before transmit. This is the sense the medium before transmit. Are you getting my point or not? So this is the basic definition of CSMA. And what you will sense? You will sense whether the medium is carrying any signal or not. What you will sense? You will sense whether the medium is carrying any signal or not. And that's why we basically say the carrier sense multiple access. Clear everyone? So we will just sense the medium before the transmit. Now under the CSMA, there are various persistent method. One is the first one is the non-persistent. Second one is the one persistent, and third one is the P persistent. Let's see one by one what is the non-persistent method, what is the one persistent method, and what is the P persistent method. Suppose if the rate of collision in this situation is x, then in this situation it will become x minus y, and in this situation it will become x minus z. Here the value of z is greater than y. So ultimately the rate of collision in case of non-persistent is high, then in case of one persistent is lower than non-persistent, in case of P persistent is lower than 1%. So how you are just defining three different kind of persistent method in case of CSMA. So all the persistent method based on the sensing parameter, which is the carrier sense. Okay, let's see. One is the non-persistent. See, I'm just creating a diagram to make you understand about the protocol. Okay, so this is the timeline. And this particular part is just representing the medium is occupied or busy. This particular part is representing medium is busy, and this particular part is representing the medium is idle. Okay, so just see over here. I'm assuming a network like this. There are only three different nodes which is connected with a common Okay, this is the node A, this is the node B, and this is the node C. And just imagine the node A is accessing the medium. At the particular time instance, the node A is accessing the medium. in that particular time instance, what the node B and C will do, it will remains idle. It will remains idle because whenever the node B and C will sense the medium, it will found the medium as a busy. So if the medium is busy, then it will stop transmitting and it will wait till the medium will become the idle. Are you getting my point? So here we are assuming this medium is busy and busy by node A. If the medium is busy, then it is occupied by node A. So in that situation, what the node B and C will do? Either they can continuously sense, suppose in this moment the node B has sensed the medium. In this moment, means this is the timeline, okay, and this is the t is equal to like 0 time where the node A has started the transmission, and whenever the node B is sensing, this is the t is equal to 2 millisecond. Okay, so at the t is equal to 2 millisecond, whenever the node B will sense the medium, it will found the medium as a busy. So what it will do, either it will continuously sense the medium till the medium will become the idle, or after the sensing and once it will found the medium busy, it will wait for some time and again it will sense. So there are two different kind of possibility. Either you can continuously sense the medium to check when the medium will get free, or what you can do, after sensing the first time, whenever you will find the medium busy, you can again sense the medium after some time. Got it? So here the node B has sensed the medium, and after just some time the node C also sensed the medium. So suppose the node C has sensed the medium at 3 millisecond. At 3 millisecond, it also find the medium busy. So what are the possibility there? Both the node will both the node will continuously change the medium. Continuously change the. Are you getting my point or not? So here, what kind of thing is happening? That is the continuous sense. Continuous sense. So here in this age point, in this particular age point, both the node B and C will found the medium idle. And what B and C will do, both will transmit their data frame and it will be collided. It will be collided. So this basically appear in case of non-persistent. Now in this age point, both found medium idle and transmit their data frame. Got it? And definitely the collision will occur. So this is the method in case of non-persistent method. So in this method, the percentage of collision, okay, the percentage of collision is approximately calculated as 47%. Okay, I'm just writing the value which is given inside the book. GATE is not going to ask what will be the percentage of collision over here. Are you getting my point? GATE will ask you the logic, whether you are making the continuous sense, then you are transmitting, or what kind of approach you are using in case of non-persistent method. Now let's see the one persistent method. One persistent method. See, our ultimate, what is our main objective? Our ultimate objective is to reduce the rate of collision. Our ultimate objective is to reduce the percentage of collision. Again, we are imagining the same situation. There are three nodes connected with a common there are three nodes connected with the common link, and this is the time. Okay, and this particular channel or medium is occupied by some node. Okay, means this is representing the medium is busy, and this is representing the medium is okay, and this channel is occupied by node A. Now let's see whenever node B will sense the medium at particular time instance, it will found the medium busy. So what decision node B will take? Either it will continuously sense. So already we have assumed that situation in case of non-persistent method. So in this situation, it will never continuously sense the medium. So whenever the node B will found the medium as a busy, so rather than continuously sensing the medium, it will wait for some time. It will wait for some time. Suppose imagine a situation node B sense the medium. This is the first bit which is transmitted at the t is equal to 0, and node B is sensing at 2 is equal to 2 millisecond. Okay, now just imagine a situation node C has sensed the medium at this particular point, and again node C found the medium as a busy, and it is t is equal to 3 millisecond. So whenever node B is found the medium is busy, it will wait for random amount of time. It will wait for random amount of time, and suppose this is the time t is equal to 5 millisecond. Means after the 5 millisecond we have started from the 0, and after the 5 millisecond we are assuming the transmission of frame will be completed. But in this situation, what is happening? Whenever the node B is finding the medium as a busy, it will wait for some time, and after that time it will again sense the medium. So suppose it is waiting for the random amount of time, which is nothing but 5 millisecond. This is the random time. Means what you have to write? Once in this particular method, once any node found medium busy, it will wait random amount of time. It will wait random amount of time, and again sense. Got it? And again sense. So what is happening over here? Node B is waiting for the random amount of time. So, and node C has taken, suppose node C has waited for just take an example for 6 millisecond. So there is a gap of 1 millisecond between B and C. So 6 millisecond means if it is taking 5 and it is taking 6, what will happen? So from the 2, 5 it will become 7, and from the 3 and 6 it will become 9. So after the 5 millisecond, whenever the node B will sense the medium, in this point the node B will sense the medium, and it will found the medium as a idle. So it will immediately transmit its data stream. So now the medium is occupied by the node B. So if the node B is sending its data frame, and after the timer expire by the node C, so here the node C will again sense the medium. So if node C is again sensing the medium, what the node C will realize? The medium is busy. Are you getting my point or not? The medium is busy. So again the node C will pick a random amount of time. So suppose since this is the random time, so it is picking 4 millisecond. So again it will pick for the 4 millisecond, and the node C will again sense the, so here it will found the medium and it will transmit its data frame. So my dear friend, what we are observing, we are observing up to this time the medium is unutilized, and up to this time here the medium is occupied by the node C. So what we are observing here, the medium is occupied by the node B, and here the medium is occupied by the node C. Got it? But what we are observing ultimately, that this particular time, these two times are unutilized. 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 So in case of one persistent method, we are reducing the rate of collision. We are reducing the rate of collision. Again, there is a possibility like, suppose the node B has picked the waiting time of 5 millisecond, and after the 1 millisecond, the node C has sensed the medium and it found the medium as a busy, and node C has picked the, suppose in this situation node B picked the 5 millisecond, and in this situation node C picked the 4 millisecond, and there is a gap of 1 millisecond. So what will happen? Again the collision will occur. So even though you are picking the random amount of time, so there is a possibility the both the node will pick the same random amount of time, and if such thing is happening, then again there is a possibility of collision. So ultimately you cannot, like, you cannot just remove the collision, but you can reduce the rate of collision. Are you getting my point or not? So in this situation what is happening, we can easily reduce the rate of collision. So in this situation, the percentage of collision is equal to 18. Okay, 18%. So by applying the logical thought, you can easily realize how we are reducing the rate of collision. So only one drawback is, for some period of time the network is remains unutilized. So this is the drawback of one persistent method. One persistent. Okay. So if the network is being unutilized, this is not a useful idea. We want the medium busy as much as possible without any collision. So the last method is P persistent. See over here. P persistent. So what is the P persistent? It just choose the best approach of non-persistent and one persistent. Okay, so it uses best features of non-persistent and one persistent. What are those? So in P persistent, first of all, the medium will be continuously sensed. The medium will be continuously sense, and this is the method of non-persistent, and the second thing, it basically uses, rather than selecting the random time, selecting random time, it select time in multiple of multiple of tf. So what will happen, it will choose a random value, it will choose a random value is equal to r. Okay, and the waiting time will be calculated in this particular form. Waiting time will become r into tf. So rather than selecting the waiting time as a random, it will select a random value as a random value, and it will just select the waiting time in the multiple of tf, where tf is the transmission time of a single frame. So here the random value r belongs to 0 to 2 to the power k minus 0 to 2 to the power k minus. So what is the k? Everything I will discuss later on, because this is the part of exponential backup algorithm. So in exponential backup algorithm, I will discuss each and everything. Exponential backup. Once I will start this particular topic, I will explain each and everything. So just have some patience. So now let's see what is the scenario in case of p persistent method. Just see. So in case of p persistent method, what will happen? This is the timeline. This is the timeline, and this basically representing the medium is busy, and medium is busy by node A. And suppose in particular situation, node B has sensed the medium here and node C has sensed the medium here. So what will happen? All the node will continuously sense the medium. All the node B and C will continuously sense the medium. So in case of non-persistent method, what we basically do, so at the ace point, whenever both the node is finding the medium idle, this is the busy part and this is the idle part. So at the ace point, both the node, whenever finding the medium as a idle, they immediately transmit their data frame. But here that thing will not happen. So whenever both the node B and C will found the medium as a idle, immediately both will choose a random value, or you can say random time, in the form of in the multiple of tf. So again, this is a kind of slotted aloha, yes or no? So suppose B has selected the random value r is equal to 2. So the waiting time for the node B will become 2tf, and node C has selected the random value is equal to 3. So the waiting time for the node C will become 3tf. Okay. So what will happen over here? Node B will wait for the 2tf time, and it will sense the medium over here. So we have divided the entire time into the slot. Ultimately what we are doing, actually we have divided the entire time after this into a slot, and each slot is nothing but a tf, that is the transmission time of a single frame. So in this point, whenever the node B will sense the medium, it will found the medium idle and it will transmit its data frame, and the timer of the C will expire over here. The timer of the C here, you can easily realize here which node is sensing the medium, node B, and here which node is sensing the medium, node C. So here the node C will transmit their data frame. If such thing is happening, no collision will occur. So in this situation the percentage of percentage of collision is equal to almost 10 to, so you can check it out. You can check it out. And tomorrow I will tell you how to calculate the throughput, how to calculate, or what is the formula, calculate the utilization and throughput, utilization and throughput. Okay, but if you will talk about the gate point of view from the slotted aloha or csma, they are not asking anything from the like utilization and the throughput, because this is the well known formula. So my dear friends, tomorrow I will discuss the csma by CD and CSMA by CA. So just be with me. If you want to learn each and everything related with the media access control, then just be with me. So my dear friends, that's all for today. So if you want to get the subscription either in the plus course or the iconic course, you can use the code IFA and immediately you will get minimum 10% discount. And never forget to subscribe this particular channel. Press the bell icon button to get all the notifications, so that whenever I will come online, you will be able to access all my lectures. Put your valuable comments, because your one valuable comments will inspire the many students and they will join the online learning platform, okay, in this COVID time. So this is my telegram number. For any query you can personally contact me on my telegram number 92649545. Thank you very much. Again, we will meet at 10 p.m. Bye, take care, have a tea, enjoy and keep learning.